conditioning, and we're going to talk about troubleshooting and the RMA process, the common issue that you might find. And I'm also going to try and share a knowledge base, so websites and videos where you can always find useful information to help you in your job. I do encourage you, if you have questions, I do encourage you to ask them. We're going to have at the end of at each section, we're going to have some Q&A space. But yeah, if you think that there's something that you want to point out at that particular moment in time, I do encourage it. Don't worry. Okay, so what we are looking at our hybrid solution for actually, as we call it, a intelligent energy independent solution, is comprised of a few products, which well, the star for it is the Solis RHI single phase, which ranges from 3.6 up to 6K. These inverters are compatible with low voltage batteries. We have actually quite a long list. Might not shared there just a small bit, but the list with batteries that are compatible, it's really long. So I guess for your customers, you should be able to find something suitable, especially because now, as I know, the market is lacking products. Well, the next one is going to be, it's the three-phase system. It ranges from 5 to up to 10 kilowatt, and is compatible with high voltage batteries. These are batteries up to 600 volt connection. And the second, which has also been extremely popular on the UK market as well, is our solution for retrofitting installations which already have a PV inverter on site, and for customers who want to add additional storage capabilities to their systems, meaning that this inverter will be installed, connected near the PV inverter, and it will work as a way to maximize that self-use, to store energy into the batteries when there is available energy. There's an excess of energy that is being normally exported into the grid and just being discharged when there's a need for it. So this is what the 3 kilowatt does. I'm sorry? Okay, sorry, I thought that someone had a question. So let's take it. These are the 3. Let's just go through their technical specification real quickly. What I want to point out, so now coming back to the Solis single phase hybrid inverter, the current naming that we have that is on the market is the RHI 3 to 6 kilowatt, 48, meaning the 48 volt battery compatibility energy storage system, ES 5G. But with the new units that will be coming in from the factory, you're also going to meet this type of naming is the S5. So it's the 5th series hybrid single phase 3 to 6 kilowatt low voltage. The L comes from the low voltage. These will basically look just the same and will have the same functionality. So just wanted to point that out, just in case you see these differences. What I can tell you about these is on the PV side. Depending on the size of it, you can have either 11 amps or 15 amps PV panels per string input, all of these have 2 inputs with 2 individual MPPT, and they do have, depending on their ratio, they do have a quite high DC to AC ratio, meaning that you can install, I don't know, for example, I think for the 3.6, we're going to see it a little bit lower below. You can connect on the DC side to have a DC to AC ratio of over 1.7. So let's go through. Let's see if I have this value here. No, unfortunately not, but I'll have it a little bit later for you, and I'll show you how to check in the technical data sheets, so you can identify for each model what is the maximum recommended PV input that the system will allow, because that is, I guess, it's very important when you're designing your system. So additionally, the compatibility, the battery compatibility list is definitely a lot of lithium batteries, but they are also compatible with lead acid batteries. For this, in order for the system to work properly, they're going to need additional, because the lead acid batteries do not communicate over CAN with the inverters. They're going to need additional some temperature sensors that we can help provide. So if you ever have such a system, you're working on installing such a system, get in touch with us, and we can help you provide that to the customer and to the installation. I will show you a little bit on the bottom view and the system connections. All of our inverters that we're selling on the UK market currently all include a DC switch. So in theory, you won't need an external DC switch unless the regulation asks for it. As I mentioned, there are 2 DC inputs, so this DC switch is going to cut off the input on both DC inputs. Additionally, we have the battery connections, plus and minus, where you would normally connect the power cables. The CAN communication port, which is actually an RJ45 plug, which is used for connection to the battery control management systems, the BMS, as it is called. And if we're talking about a lead acid, there you would connect the battery temperature sensor. Additional for UK, of course, we have the DRM, the demand response manager, that is required. Additionally, there's an RS485 meter connection that is, of course, suited for setting up communication between the inverter and the meter that comes with it in the box of the inverter. There's a normal 4-pin communication port that all our Solis inverters have. These are used to connect the data logging, usually the data logging stick in this case, because this is the most used data logger for the hybrid systems. The data logging stick is communicating via RS485, and it can be either Wi-Fi or LAN or GPRS. We're going to go into that a little bit later, but I would definitely, I'm going to mention it from now, I would definitely recommend that all the hybrid inverters that you are installing with your customers to have a data logger connected to them, because this helps quite a lot with troubleshooting remotely the systems without an extra need for you to go on site in case customers call and raise an issue with the system. So some of the things can be easily sorted out remotely, either by us or even by you. We'll talk about that a little bit later. And very important, now we have the AC grid connector, which will connect the inverter to the main AC grid. And secondly, we have the AC backup port, which is the wonderful thing about this hybrid inverter, which allows the customer to connect to it all its critical loads that they can then power either during power outages or in case they lose their AC connection, with power coming in, of course, from the PV and from the battery if available. This is how the system diagram will look like for a single phase inverter. This is here we have the RHI with its PV connection and its battery connection. Additionally, we have here the main grid connection point, which has its normal consumer load connected in the distribution box. Here to the right, we can see the meter that comes delivered with the hybrid inverter, which is a crucial part of the system, without which the actual functions for PV optimization will not work if this meter is not installed in the proper location and in the proper way. What this meter does is constantly, it has a connection for voltage, for line and neutral. This is to power up the inverter, the meter, but also monitor and get the voltage values. And additional, it has a CD clamp, which is connected to pins here. As we can see 5 and 6. This CD clamp will constantly monitor the values of current, the energy export and import from the grid. This is being collected by the meter and transmitted through the RS485 meter communication cable to the inverter. The inverter will take its decisions based on this information coming in from the meter. The inverter will take the decisions if there's going to start charging or discharging the battery in case it detects an export of energy to the grid. So if your hybrid inverter is generating energy and it's more than what the loads are able to consume, then normally this energy will be supplied to the grid. But if the system is set up, the settings on the inverter are set up in such a way, in self-use mode, as we call it, then the hybrid inverter will send control command and it will start charging the battery with that excess of energy, just in order to get this value for energy being exported to the grid as closer to zero as possible. So it will not waste any kind of energy. Of course, if the batteries are full and there's no room left to it, of course that energy will flow back if it's not flow into the grid if it's not consumed by the load. Additionally, there's a the backup port that I was mentioning earlier. Here, the system, the inverter will have connected the critical loads, as we call them, that the customer might have, and which can be linked, connected here and be supplied in case there's a power outage. These loads can normally be supplied from the grid itself through the inverter when there is grid available. But otherwise, if there is an interruption, they can be supplied from the battery and PV side. We can go a little bit later into these working modes and how the system works. And this is valid not just for the single phase, but this is valid also for the 3-phase and for the RAI as well. I was mentioning a list with the compatible batteries, but this list gets updated, I think sometimes even every week with new compatible batteries. This is always, you can find it on our website in the download section, in the data sheet section for each model. I'll show you where you can get it. We'll talk a little bit, but not get into too much detail on the 3-phase hybrid inverter. So as I mentioned, this ranges from 5 up to 10 kilowatt, 3-phase being compatible with high voltage batteries. The main difference, I guess, in between this and the single phase is just that, so first would be the fact that it's a 3-phase system, and the type of battery which are compatible with it. Otherwise, all the functionality that is embedded into the single phase, we can find it as well here for the 3-phase hybrid inverter as well. Again, we have an AC grid output, as I mentioned, either from 5 up to 10 kilowatt. And again, the backup ports, depending on the sizes, can withstand, can supply loads for 5 up to 10 kilowatts for each, depending on the model. The backup switching time, it's less than 40 milliseconds. For the single phase, it's even it's less than 20 milliseconds. We're always working into improving that. So in case there is a power outage, when you're sitting in front of your computer and you have those that load your computer connected to the AC backup port, you would not even feel it. The switching time is so fast that your computer will stay on. It's just like an UPS. Of course, that's given if there is enough energy available in your batteries to help you with that. When we're talking about the connections, again, this is going to be just the same as for the single phase. There's a DC switch which controls the input for all two MPPTs. Each MPPT has two inputs. We have a battery connection, CAN communication for communication with the battery, the communication port for communication with the data logger and the monitoring system. The DRM port, which is normal. There is a DRS-485 for communication with the meter. And what the 3-phase additionally comes with, it's a local Wi-Fi access point, but this is used only for local configuration. So this local Wi-Fi cannot be linked further to the internet, but can be used with the Solis TechView app to help you control and also set up the inverter during the commissioning. And once again, the AC backup and port and the main AC grid connection port. The system diagram for it looks just the same. It's the three-phase, but it's the three-phase system. This is the main AC grid connection point. Again, with the loads, at the main AC incoming power supply, we're going to have always the meter. The meter must be installed at this point in order to be able to monitor the export of energy or the import of energy, based on which it will control the discharging and charging of the batteries. This one comes with, of course, 3 city clamps for each of the phases. For powering up the meter, you have the pins 13 and 12, and these will help supply the meter with the power. And for measuring the voltage on each phase, there are pins 1, 2, and 3, and the neutral on pin 4. All these connections need to be done correctly in order for the meter to get all the data that needed for the inverter to work. I haven't added this for the single phase, but I'm gonna mention it now because it's really, really important. These cables that you would be connecting the CD clamps with, these should never be extended. So this meter should always be installed on the main AC incoming power supply. And you can extend the RS485 cable that connects the meter to the hybrid inverter. It's really crucial that you do not extend the cables for the CD clamps, because these will, I think the maximum length is, I don't know, somewhere about 10 meters. If you would extend them to more than that, it will lose the signal and the meter will get no information for the CD clamps. Here again, we have the list with the batteries which are compatible. The list is longer. I'm going to show you, as I mentioned a little bit later, how it works. Let's go a little bit more into detail on the operation modes for the hybrid inverter. So these apply to the entire range for the single phase hybrid, the 3-phase hybrid, and also the RAI, the AC coupled. It's very good to know. So we know that there's always in the home, in the household, there's always a mismatch in between what the PV is generating. The peak will be always during the time of the day when there's mostly no consumption in the household, and then early in the morning and late in the evening, the house will start consuming, and all that energy normally is being fed into the grid and can be even wasted if the tariffs aren't on the customer side, the generating tariffs. So what we're trying to achieve with these hybrid installations, or even with AC coupled, is to try and balance the consumption and the generation by having storage into the batteries and make that energy available when it is consumed, so it doesn't go to waste, or even lower the cost for energy. As always, during high peak consumption times, also you can get higher tariffs. So normally during the day, how this should look like the PV is generating energy from the PV input. That energy is either consumed locally or it's being exported into the grid. Solis meter, which is always should be installed on the main AC connection point, needs to always constantly monitor that export and import of energy coming in from the grid. Actually, during the day, you're going to almost always have an export if the sun is shining. So that energy should be redirected into the battery and being stored to make it available at a later time. This way, the CD clamp, then it's going to, when that battery, when that energy is being pushed into the battery, then the CD clamp is not gonna see any more energy being fed into the grid, and it's gonna keep, the inverter is gonna keep that value constant in order to charge the battery. All this information is available on the monitoring platform for our Solis inverters. If this is connected through the data loggers to the Solis cloud monitoring platform. And for the customers, I think it's very important because they feel that they have control and they know what their system is doing all the time, even if usually they're not at home. Many of them are during the weekends are very happy when they're at home and they're able to monitor their systems every 5 minutes. So this the Solis Cloud gives them this option. The diagram, the consumption diagram, will always be available for them as long as the system is connected to the internet. Okay, so during the nighttime, normally the PV it's out, no PV generation. So the load should start getting their power from the grid. What the Solis meter does, it reads that energy being consumed, sends this information to the Solis hybrid inverter, and the inverter, by communicating with the battery management system, sees that it has energy available, and it will start discharging this battery in order to cover these loads and make this value that is being read by the CD clamp as close to zero as possible. So that it will consume that data that has been stored during the day, make it available now for the load. Okay, so in order to do this, we have multiple working modes. These are available to be set on the inverter screen in advanced settings. The systems normally come with the self-use mode activated. Self-use mode is this mode that I have just explained a little bit, this working logic for maximizing the usage of PV energy. But what I have to probably tell you is that this self-use mode additionally has an option which does not allow for the batteries to be charged from the grid, and this should always be activated manually. I'll tell you a little bit more about how the battery system is set up, and you're going to understand why that option needs to be enabled. Charging from grid, it helps during, for example, winter times, long periods with low PV irradiation. You're going to need to keep those batteries alive, and this will have to be done from the PV not from the PV, but from the grid side. And you have to also explain this to the customer because those batteries can go on for so long during low PV radiation periods, and they're going to need this. So self-use mode, that is the default mode in which the system comes in. But there are another modes like feeding priority that may be used. I don't think this is something that I have never seen it as a need for UK. Feeding priority would be to, the logic is to feed the excess of PV to the grid in order to gain subsidies. So it's not going to be stored in the battery, but the first option would be to have it being injected into the grid in order to gain tariffs. The third one is the backup mode. So the backup mode is very useful for systems or which are installed in areas where the grid might be very unstable. And what the customer is left here, he has the option to keep the battery at a certain limit, a certain state of charge. For example, they can choose to always have the battery topped at 50% when there is a grid connection available. So it will not be discharged into the loads under 50%. And in case of an outage, that 50% will become available in order to supply those critical loads. And the third mode is the off-grid mode. The fourth mode, sorry, is the off-grid mode. This is for remote locations where there is no grid available. The inverter is able to operate without having a connection for the mains, and it will only work as with the PV and the battery, and it will feed power through the AC backup ports to the loads for that location. So again, we're just gonna go a bit through these. So the logic of the auto mode, or the self-use mode, is that when the PV is generating more than what the house is consuming, instead of injecting that energy into the grid, you're gonna have it pushed into the battery if there is enough space available, if the battery is not full yet, or in some cases, depending on the battery management system, because actually the battery management system, so that's a third party software provided, of course, by the battery manufacturer, and that battery management system is the one that it's actually is able to set some limits for charging and discharging currents. This is either, for example, if a battery is completely full, the BMS will set up a zero charging limit to the inverter. So it will not allow the inverter to push more energy into the battery. But this can also happen depending on the state of health of the battery, or in order to maintain a good health. That limit can be sometimes can be lowered. For example, you can have a 50 amp limit coming in from the battery, but it's sometimes for lower temperatures. It can even drop to 10 amps. I have seen it many times when batteries are installed during winter time and they're installed in colder places. We have seen that the battery management system is limiting the current in order to maintain the health of the system. So again, when as I was mentioning, when the solar energy is low, that's in this auto mode will control the hybrid in such a way that it will, instead of drawing power from the grid in order to supply the loads, it will start discharging the batteries and lower that grid consumption. This will be done for both the normal loads, which are connected to the main AC port, and to the backup loads. As I mentioned earlier, these are being fed through the inverter from the AC side, no matter if PV or battery are available or not. The next working logic for self-use, this can also work in parallel with the self-use mode. If the customer have some can have either multi-stage off-peak tariffs, they will be able to program the inverter. For example, if they have a lower tariff during nighttime, they're going to be able to charge their battery during nighttime and use that energy with higher during times where higher tariffs are applied. For example, in morning time or in evening time. This working mode is 100% compatible with the self-use mode, because you're going to have, for example, you can set up the battery to be charged during 12:30 in the night down to 4:30 in the morning. And during the rest of the period, the system will work in self-use mode, and it will charge and discharge the batteries just based on the PV generation and the grid consumption. And this is, I think, it's very important for the customers to know that they have these options. All these, as I mentioned, they can be changed locally on the inverter screen, but now we are working on having these available for the end users and for the installer accounts on Solis Cloud. We are very keen on launching that really soon, because I think it's a very important part in giving full power to the customer over his installation, even remotely. I know that many times these systems are installed in lofts, which make it very hard to be accessible for end customers. So we're working a lot to have that. Probably I'm hoping that we're going to have it next month. We're going to, I guess, make an announcement or a launch, because I think it's a really big thing. So when it comes to grid independence, we have the battery reserve mode or the backup mode, as I mentioned, where the system, customer can set up an SOC limit. SOC, I don't know if I mentioned, for maybe not everyone is familiar with the SOC term. That's the state of charge of the battery. That's going to tell you how much energy it's still available in the battery, and that's always in percentages. So when the battery is full, you're going to have a 100% SOC. So when you are in battery reserve mode and you are selecting this mode, you are asked to define an SOC value below which the hybrid inverter will not discharge the battery when it has a grid connection available, and it will keep it as a reserve in case there's a grid outage. So when this happens, when there's no connection to the grid, then just the backup loads will be supplied from the PV and from the battery. In the switching time, less than 20 milliseconds, it happens automatically inside the hybrid inverter, so there's no need for an external switch. But what we advise that there should be, I'll tell you a bit later, I have a diagram, there should be a changeover switch just for maintenance purposes. So in case you have the hybrid taken out or out of service for some reason, there should be a changeover switch to switch the supply for these backup loads to the grid. It can be manual, it can be automatic, depending on what the customer wants or needs. But yeah, it does need to be there. So the working mode for the off-grid. Here you don't even need a meter to be installed with the Solis hybrid. The connection will only be on the backup load with the loads that are connected as critical load. The hybrid is the one that is actually creating the grid. And you're going to have the PV inputs and the batteries, and all this doesn't even have to exist. But of course, for these type of systems, you have to be careful how you design the capacity of the battery in order to be able to supply those critical loads throughout all periods. And the last working mode that we have is actually it's a working mode where the Solis with the hybrid inverter can work just as a normal PV inverter without having a battery connected. This is ideal for customers who might not, for example, want to invest for now in a storage, but they want to have the opportunity to add it a little bit later. So you can install the Solis hybrid just as a normal PV inverter and add the batteries at a later stage, and the system will work without any other problem. Okay, and
we want to do a little bit of break. I think it's approaching 11.
Yes, that's
and
that
I
would
can
be
see
perfect.
that somebody has been raising the hand for a while.
I'm sorry. Okay, that's great. Please, let's have a few questions right now, and afterwards we can take a
we can take a maybe
break.
5 minutes break.
Exactly.
Atom 415V, you are muted. What question do you have?
Oh, yes, please. When you were talking about the hybrid being set up for priority, battery grid, etc., because of people with feed-in tariffs, if somebody's on in the UK the high feed-in tariff, would there be any losses to them with their feed-in tariff if they set up the battery as priority over the grid on the setup? Because obviously, you know, a lot of people do not get monitored on the export on the old feed-in tariff system.
Okay, so these, as I was saying, these working modes work in parallel. So, for example, if you set up your time charging, so you want to export all of the energy that is being available during a specific period of time, all that energy will be fed into the grid. So it will not all the energy that is available, of course, because the loads will also be powered from that energy that is being exported. So I guess there is some loss, if you wanna call it that. Am I answering your question?
I'm not sure, because under a normal grid-tied inverter system, it's metered by a kilowatt-hour meter. So the customer on feed-in tariff will get paid for whatever that meter logs. So
okay, but that will always log what is being exported, right?
Yes, but so
Not what is being generated.
Yeah, so if they was to prioritize their, if we retrofitted the system to an existing feed-in tariff customer, if they did then go for the battery as the priority for the charge, they wouldn't lose any.
If you set up the battery as a priority, I mean, to be charged, then yes, you would lose that. I mean, that energy will be stored and it will be lost locally. Yes.
Because it wouldn't go through the meter.
Yes. Yes. Exactly. Yes.
That's fair enough. And you know, if you've got a customer who's got, let's say, an old inverter that's coming to the end of its life, and you were to offer them, what would you prefer? The hybrid or the AC coupled battery system?
Well, I guess it depends on how old that PV system is. I mean, if you think it is not going to withstand too much, probably I would recommend you the hybrid to replace it. But if it's just an installation that's just a few years old and you want to add storage capabilities to it, I mean, it happened with also with Solis inverters. We have a lot of customers who have Solis PV string inverters, and they would just add the RAI AC couple to it. But I have also seen customers who wanted to expand their production capacity, so they can add, for in this case, a hybrid inverter additional to that.
Okay, that's great. Thank you.
Very welcome.
Yeah. If no one else have any more questions, we will take a break and we will resume in 5 minutes.
Okay.
Okay, cool.
Thank you.
Thank you.
Good morning.
Good morning. Hello. Yeah. Hey, Carmen, you are muted.
Yes, I know. I was just getting ready. Okay, I guess we can continue.
Yes, please. Thank you.
Great. So we're just gonna talk a little bit about system design, just to give you some more like hints, I would say, on what you look for. We are working now. We have and I'll show you how that looks like. We have a Solis design tool that we are using, and all of our customers can use it online. But this is more for the PV side, and not for the battery storage. So I guess maybe in the future we're gonna help you give that that bit of support for you when you're designing the hybrid systems as well in terms of storage. But as I was mentioning earlier, what we're trying to do here is just to match that that consumption that happens almost always out of sync. So the loads from households are mainly during morning and afternoon and evening, and the PV consumption happens mostly during the day, of course. All loads are dynamic, and they need to be supplied. It's not so. It's not a matter of deciding which loads are important, because each one has its own importance. But we have in PV is available only in some periods of the day. So that's why we want to shift that availability from the daytime to, for example, evening time. So here with the yellow is that excess of solar production, and the blue the blue curve. These are the loads that are not being met by the are not being covered by the PV energy generated, and only these with green, these are the loads that are supplied for the solar, because of course you have in households, you have some permanent loads, for example fridges or heating or some lighting. So the rule of thumb is to size the solar generation for the loads in order to cover the loads, and size the batteries to cover that excess of solar production, which of course is it's really difficult to estimate, but for each type of households there are let's say some baselines that you can follow, and you have to make sure that when you are doing the design, you can do a winter design and a summer design. So based on the summer design would be based on the PV that's going to be available during the summer when it's higher. Wintertime, of course, you're going to have some really dull days where you might have no PV available whatsoever. So you need some extra storage in order to cover some of those consumption. I was mentioning a little bit earlier about the backup circuit design and the need for having an AC changeover switch. So even if the inverter inside has its own automatic changeover in order to switch the power supply for the critical loads from being supplied from the grid to being supplied from the battery. Additionally, you're going to need this changeover switch in order to be able to supply these critical loads, even if the inverter is out of service or requires maintenance. It needs to be this. I haven't mentioned this. I mean, it's quite okay, and it's quite usual to have these systems installed without making any type of use for the backup port. That can be left unconnected and unattended. So it's not mandatory. Not all customers require to have their critical loads powered when there's a power outage. Because also this will involve extra costs, as there's a lot of work. Those critical loads need to be split, and they need to be disconnected from the grid, put on a separate circuit, and connected to the load. So often, as I mentioned here, it's easier just to place a plug circuit below the inverter in case of emergency. So that plug can be used if there is no grid. You can just plug in whatever load you have. Maybe you have a fridge that you want to be powered on during an AC outage, so you can just plug that fridge into that circuit in case the connection drops. I want to talk with you a little bit about the AC coupled. As I mentioned, this can be installed with any type of existing inverter, PV inverter unit. It doesn't have to be Solis. It can be anything else. What it's really important is here we have the RAI, which has a bidirectional DC to AC inverter unit and a DC to DC in order to charge the battery and control the discharge of the battery. And it's very important that these these will be connected onto the same AC connection point. So that the RAI will constantly see the generation, actually the export of energy that is being put through this connection point, and it can decide to charge the batteries if it sees that there is an excess that hasn't been consumed by the loads and is being exported to the grid. It's going to take that and on the AC side, and it's going to charge the batteries with it. In case it sees an import, because there's no PV energy available from the PV string inverter, it will start discharging the battery in order to power these loads. So quite useful. What I have to mention here, that for now, these units cannot be paralleled on the grid port for no reason, for reason that it's very obvious. If they're connected to the same connection point, their meters will always monitor 2 times the energy that is going through that connection point, and they're going to fight with each other for that same energy. So for now, these cannot be paralleled. What you can do, if you have a 3-phase system, you can connect it on the main AC port. You can connect it each on one inverter on each phase, but not on the backup port. You cannot create with them. You cannot create an emergency power, a 3-phase emergency power supply. So just on the main AC port, if it's really needed. So what is in the future? Well, soon, I think this year, we're going to launch our S6 hybrid inverter, and that one is going to have paralleling capabilities. It's going to be really nice for customers who want to expand their installations, because those inverters will be able to communicate with each other and just work with each other and not against each other. So let's go a little bit to the installation. I'm just going to show you a little bit about what you can find in the box that comes with the inverter, and what's not in the box, and what would be the main things that you should look out for. I think most of these, yeah, you already know them, but I want to make sure that they're put through here as well. So definitely you're going to find in the box the inverter, mounting brackets, the AC plugs for both AC, main AC and backup. So both on the inverter side and on the cable side, MC connectors. And we always strongly recommend to use when you're connecting your PV to always use the MC connectors that come with the inverter, and don't use any others, because it's very important in terms of compatibility. You might have some, if these connectors don't match up 100%, it might lead to damages caused to the PV inputs, because there's going to be an increase of resistance in there. Even if you have crimped them tightly and right, the resistance will rise, and it may cause damage, melting of the connectors. So always use the ones that came with the inverter, because that's why they're there. Additionally, you're going to find the RJ45 plug for connection for the DRM, but I guess there's nothing. With that, so the battery cables, the power cables, but these are just for the single phase, because normally for the 3-phase with the high voltage batteries, all those are provided by the battery manufacturer. So you will not find, for the 3-phase, you will not find those in the box. Additionally, you have the CAN communication cable. You have the RS485 meter cable for communication with the meter. Of course, the meter itself with the CD clamps and the user manual or the quick guide, which I know that no one has time to always read, but I don't know, sometimes you might find it helpful. What's not in the box, definitely you won't find a battery. The battery it's a third party. We don't manufacture batteries, but we do, as I mentioned, quite a long list of batteries which are compatible. It doesn't contain the battery DC isolator or the battery connection between the battery and the DC isolator. No other standard solar equipment or the bypass box. In terms of inverter connections, I think we already gone through this quite a few times, so I won't take too much of your time with it. I'm just gonna talk a little bit more about the meter connections, which, as I told you, they are so important. The meter, it's one of the pieces of the puzzle that would always, if you need to put it in the it needs to fit in the right spot in order to have the system work properly. So always the meter is the one that needs to monitor the consumption on the grid connection point. So it can always know what is going in and out. The CD clamp normally has an arrow on it. That arrow usually it's towards the grid. But and if that CD clamp is not installed in the correct direction, the flow of energy will be displayed reversely on the meter. But I will show you some tips and tricks on how to test that, just to make sure that it is installed properly. It's really easy to find out. As I mentioned, it's very important for that CD clamp cable to not be extended. You can extend this one as much. You can extend up to 100 meters without any problems. Sometimes if you double up the pairs, you can even go up to 200 meters. And no, there's no option for a wireless meter for now. So everything needs to be cable connected. That would be what I've mentioned here. These are the meter connections for the hybrid inverters. For the RAI, for the AC coupled, they're almost the same, but there are some few differences. So the RAI, the first generation that we distributed to the market, that one did not have actually a meter. It only had a CD clamp. That CD clamp was installed on the main AC connection point, and that would just send directly, it would feed information into the inverter, and based on that, the RAI would either decide to charge or discharge the battery. So that was a good thing, but because this design was not allowing any type of information regarding what the PV inverter was actually generating, this meant that also there were no consumption values available on the inverter itself. So that's why we have, and also this CD clamp could not be, the cable for the CD clamp could not be extended. So always the RAI was installed somewhere in a more remote place because it needed to be right on the grid connection point. And it was causing a little bit of troubles. So that's why we have now launched the version with the meter integrated. So when the inverter comes it's delivered with the meter itself, but also it comes with a CD clamp. You can either choose to have the CD clamp as it was before, CD installed on grid, or if you are installing the meter as well, then you have the option for CD installed on PV inverter. What does this mean? When the CD it is installed on the PV inverter, should be installed on the output of the grid tied inverter, so it can constantly know what the system is generating. And based on this value and based what the meter is measuring as export to the grid, that difference would mean that that's the consumption value for the customer. This is important only for this reason, to offer the customer that option to monitor his loads. But otherwise, in terms of how the system is operating or charging or discharging, it wouldn't necessarily make a difference because the meter will be sending this data. So the CD clamp can, if you don't have the means to install the RAI inverter next to the grid-tied inverter, there's no problem if you don't install this CD clamp and you install only the meter. It might sound a little bit confusing, so if you have any questions on this side, it would be a really good moment.
I think Kevin has a question.
Yes.
Yeah, hiya, Carmen. Just a quick question. So the power to the meter, so the live on terminal 1 and the neutral on terminal 4, does that have to come from the PV circuit, or can it be from a separate circuit?
No, it can be from a separate circuit without any problems. The actual what is very important is where the CD clamp is installed, and that needs to be, the placement of that CD clamp needs to be here on the main AC connection point. But from where you get the power supply, that's not, the voltage probably will not vary anyway too much, and you only have one line, so the power should be calculated correctly.
Perfect, thank you.
Okay, very welcome. Anyone else? I guess not, but so if you think of a question a little bit later on, don't worry. Okay, so I've mentioned the AC connections multiple times, but so all inverters have the main AC connection, and the backup one is not mandatory to connect any loads to the AC backup port, but if you do, make sure those loads are on a completely different circuit with no connection to the grid, as they will be fed from the grid through the inverter itself. Let's see. Of course, the PV connections I mentioned before. Please, it's really important to use those PV connections that come with the inverter. Try to do crimping and tightening those connectors as tight as possible. Always use a tool for, and never crimp those manually. Make sure that you have an open circuit voltage that is above the startup level, so that you will be able to start the inverter. You can also test if you have any PV isolation faults right before you connect them to the inverter. So just by measuring the negative against the ground and the positive against the ground, if you get a voltage less than 30 volts, it should be going down to 0. That should be okay. If you have voltage above that, it means that there's a fault there. So make sure you check your strings before you connect them to the inverter. The batteries, well, normally you only have to connect the CAN communication cable from the battery to the inverter. The battery management systems have already been tested to work, or those on the list, of course, have been tested to work with our inverters. So if you're just selecting the correct type of battery, then it should work smoothly. But if you do have some problems with communication, you can get in touch with us, but you can also get in touch with the battery manufacturers, because sometimes even if you find the battery in our list, it might be that that battery is an older firmware and it might need a firmware update. That's very rare, but I'm just mentioning it. As for the CAN communication cable, it's best always to use the one that comes with the inverter. That's just a straight cable. Nothing fancy about it, but we did had some troubles. For example, for Pylon-Tech, that at some point they started providing their communication cables with the batteries, but those cables, those connections were not straight. A few of the pins were reversed, and the cables were not working properly. We're not sending data. The battery power connections, these are provided. You should receive them for the low voltage batteries. You will receive them in the box, but make sure that you're using them. I'm just going to mention here that all these battery connections have a push button just for disconnection. So when you're closing them, when you're putting them on, you're just going to hear a click. But if you want to take them off, you have to press this push button to help release it. Always make sure that you get proper voltage on the battery port. I have to tell you that some of the battery manufacturers, I saw that actually if there is no load, so no inverter connected to it, you might not find voltage on the battery on the battery ports. You'll find voltage only after they will get connected, but you'll be able to read if the inverter, you're going to be able to see on the inverter screen if the inverter is measuring voltage on those ports, and I'll show you a little bit later. So how the interface for the single phase hybrid that we really love so much for this model is the big LCD screen, and this is the main page, the first page, where the customer is always able to see the PV inverter, the battery, the state of charge for it, what is being generated by the PV, what is being consumed, and also what's being either exported to the grid or imported. And also there's the AC backup port. A lot of customers are a little bit confused, because this backup port, if they don't have anything connected to it, they're still going to see this, and they might even see a very small, it's a measurement error here, and they might even see a few watts going to this. So in order to stop these questions from their side, this port should actually be disabled. And this one should disappear from here. That can be done in the control parameters. I'll show you a little bit later in the menu of the inverter. Okay, and what I haven't mentioned, so there's an escape, up, down, and enter button here. Always on the top, you're going to see a status for generating. This is a scrolling status, and it's going to also show which is the storage mode that's selected, if it's self-use or backup. enabled. Additionally, if there are any alarms active on the inverter, you're going to see the alarm LED is on, but also here you're going to see the active alarm code on it. So it can be no battery or no grid, or most of them are quite explicit. Others, you can find some description for the most common one in the user manual as well. Okay, so the menu is quite simple. You have the information, settings, advanced information, and advanced settings. For information and settings, that's you don't need any passwords to access them. But for advanced information, where, for example, you can see historical alarms, or for advanced settings, where you're going to set the storage modes and time charging modes, battery selections, these require a password, which is always 0010. This is, so it's down, down, up, enter. You can find this in the manual as well. And what is extremely important, it's this selection. Here it might be pretty obvious that the menu that you are selecting, it's the one with the light blue, and it's with a dotted outline. But for this, when you have 4 options to select, it's quite easy to know which one it is. But when there are only 2 selections available and you have to move in between them, many find it confusing, because normally the selection is darker. For this one, it's while lighter. Just make sure that you are when you are selecting something, it has a dotted outline on it. And it's just the thing is, I always, when installers call me, sometimes it's quite necessary to tell them that, especially if they're not used with this type of hybrid. Okay, so I was saying to the password is 0010. And we're just going to enter here. So this is the advanced settings, which is the most important part of the menu. Here you have the select standard. That would be the grid standard for your country. In UK, I think almost all the hybrids are delivered with the G99. But it's always good to double check in case, especially if you see some over voltage alarms on the grid side. It might be just that the standard is not right. So I'm just going to go real quickly. So you have also the option to turn on and off the internal grid relay. But the next most important thing is the storage energy set. This is where this is the menu where you're gonna set your storage modes. So in here we have control parameters. In storage energy set, we have control parameters, battery select, meter select, storage mode select, and battery wake up. The battery select, I think is the one that needs the most attention. The battery select option comes by default with user defined, but this will not help the battery properly communicate with the inverter. It needs to be the correct type of battery selected in here. So if it's pylon tech, you're gonna find it here in the list pylon, LV, or if it's BYD, it can be B-Box or BYD, or Fox, or all. You're going to find them all here. You just have to search for them. Once you select the battery model and you press enter on it, it will automatically ask you to set an over discharge SOC. So what this over discharge SOC, that's a limit that you put on the battery that it will not discharge. So the inverter will never discharge into the load the battery below this certain point, 20%. This can be adjustable. This is like a depth of discharge. That's the well, actually, the next one is the depth of discharge that the battery manufacturer will recommend. This is something that we need to set it, and we usually recommend it to be at 20%, especially during the winter times, because if there is no, if the batteries would start discharging below this percentage, then at some point it can be 1 or 2 days without PV output. That SOC will drop more and more, and at some point it's going to reach that point where the battery will just turn off, and it will not automatically reconnect when the PV gets back. So it's best to give some room. So first you are selecting the over discharge SOC, and the next one is going to be the forced charge SOC. This is the level below which the inverter will start charging the battery from the grid. As I mentioned at the beginning of this presentation, is that the self-use mode comes with a charge from grid normally as disabled, because not in all countries the customers are allowed to charge the batteries from the grid. In some countries it's even illegal, and because of this regulation we have to set that value to not allow. When that value is set not to allow, and you get your state of charge below 5%, the inverter will not be capable of charging the battery from the grid in order to maintain that over discharge level. That's why it's highly recommended to have it set to allow. So when the battery gets at 5%, the inverter will start charging the battery with energy from the grid, and it will take it back to the over discharge SOC of 20%, just in order to keep it woken up and alive during those times with no PV available. This is a value that is being recommended by every battery manufacturer. So for some it will be 5%, for some it will be 10%, or even 15%. Sometimes it's best to have it, even if they say it's 5%, it's best to have it at least 10%. This is what's the default value that we are recommending, and you will find it as already set up. And then you're going to have the modes, the storage mode select. Here you're going to have all those 4 modes. Is the self-use with the time of use, battery reserve, and off-grid mode. I'm going to show you how the time charging looks like in self-use mode. This is the screen. In order to go through all these values, you can edit. You need to press the enter button in order to go down for each value, and with up and down you can measure. You can modify each value. So the first thing is the optimal income function, as we call it. It can be either on stop or on run. If it's on stop, then all these settings below are not applicable. So the time charging, the time of use function is not enabled. But once you put it on run, then all of these will apply. So what you are able to what you are able to change over here is going to be the maximum charge and discharge current that you are allowing the inverter to charge or discharge the batteries. So this is just force charging. This is not related to the self-use mode. This is just when, for example, the customer has a lower tariff during nighttime. Then here you would set a time charging from here's just 22 to 8 o'clock in the morning. It's going to show you that you have 10 hours of charging from the grid with a maximum current for charging of 50 amps. But the battery management system will decide on the exact value used for charging. But this is just a limit that you can set on the inverter. If you wanted, for example, to charge it slowly, just in order to preserve the health of the battery, you can even set it to 10 amps, and it will not charge it with more than that. And if you don't want, for example, you have a charging time during nighttime, but you don't want the battery to be forcibly discharged. You just want it to let it be discharged in self-use mode when there is consumption that is not being covered by the PV. Then for time discharging, you can just zero it out. So set it to 0000, so it will show total discharge time of 0 hours, and it will not. This will not be applied. I think we have already talked about this. It's not in terms of commissioning, so these would be the most important things that you have to keep in mind. First, check the grid standard. Secondly, check that you are selecting the correct battery model and you are selecting the correct battery storage energy that the customer wants to use. All these can be done locally on the inverter screen, but if there are some in the future, I mentioned that we will be able to, well, you will be able and the customer will be able to change those remotely or adjust them. Some of them might want to, I don't know, in winter time, different charging modes or in the summertime, different charging modes. So we're going to give them this option through the Solis Cloud app really soon. So this is about commissioning, but what I would recommend always after you have done all this, just to check the inverter screen, because that's why it's there. It's really easy to see exactly what's going on and to interpret the data. So for example, in order for you to test to see if that CD clamp from the meter is in the correct direction, the only thing you can just ask the customer to put on a kettle. Once they put on the kettle, you should see that value for the power consumption, for the load consumption to increase. If there's PV, if there's energy available in the battery, that battery will start discharging into that load in order to cover that consumption. This is how you check that the system works properly. And I think it's really useful to just give yourself I don't know, 10 minutes before leaving site to test this to make sure that everything is right, because otherwise, I don't know, nobody likes the second trip on the same job. let's talk a little bit about troubleshooting and what type of issues you might have with the inverters. Well, I guess the main problem that you might face sometimes is just you have a completely dead inverter. It's not doing anything. So when this happens, you have to keep in mind that the hybrid inverters are powered by solar or by the batteries. If those are not available, the inverter will not start, even if you have AC connection and you have power on voltage on the AC side. Of course, the AC coupled, it's powered only by the battery during commissioning, but afterwards, once it was commissioned, it can be powered from the AC side as well. But you would need a battery connection in order to start it up. Yeah, and as I said here, solar voltage does not tell the whole story. Sometimes you might have voltage, but if the system has a startup voltage of 120 and you are measuring an open circuit voltage of, I don't know, 130, that should keep in mind that that's just open circuit. When you're connecting it to the inverter, the PV string will drop. It's going to have a voltage drop on the string, and it might not be enough to start the batteries. You might have to wait for a sign day, or even you might have to check the string. It might be that you have a faulty panel that is now not allowing your string to get to that voltage you need. Okay, alarm messages. I was telling you that in advanced information, you're going to be able to see the historical alarms. This can help you to troubleshoot the systems. You can see what type of alarms there had been there in the past, and it can help you with that. So again, in advanced information, you can only access it if you use the code 0010. You enter on it and you see here. Well, I'm going to tell you a bit about the most common battery alarms. There's no battery. The no battery one, that's the most common. That happens even if the battery is not turned on, so it's connected, but it was not turned on. It will give a no battery alarm. CAN communication failure can fail. It's an alarm related to the communication between the battery and the inverter. You can have all these, the no battery and can fail at the same time, as they are they can happen at the same time as the battery is completely turned off and not communicating. You might have over voltage, OV-BAT-V, that's over voltage on the battery side when the battery protects itself, and sometimes it even disconnects itself when the inverter is pushing power into the battery, but the battery management system didn't yet limited the current that is being allowed to be put into the battery. This can happen, an over voltage battery alarm. This can be quite easily fixed, probably with firmware from the battery manufacturer, or even if from our side we lower the SOC to which the inverter will charge the battery. An under voltage battery alarm, that's almost always an indicator that the battery is depleted, it's completely empty. And you can also check this by measuring the voltage on the battery information in the information menu of the inverter. I think, yeah, I have gone through these over voltage. Okay, yes, I was mentioning that you can see in control parameters, actually. You're going to be able to see a lot of the information from the battery settings. These control parameters are not, you should not change them. These are set by the battery management system. So it's not necessarily something that you can change, but you can just check and see if those values have been exceeded or not, because this is going to be an indication of why you are getting some of these alarms. And it might even help if you're checking with the battery manufacturers. It might help them troubleshoot with you the alarm on the battery itself, if it is on the battery. And again, the BMS internal, there's going to be some alarms with BMS in front of them, and those are alarms that are coming straight from the battery management system. Normally, we don't have too much information on these. They just come from the battery, but it can help if you're discussing it with the battery manufacturer. On the other side, there's going to be, so in information, I told you in the information menu, you're going to have some screens that will always show you the status of the system. You're going to see the voltages on the PV. You're going to see the grid voltage, the battery voltage. That is actually the one that is being measured by the inverter on the battery terminals. Then you're going to see some generation details, the amount of energy that has been generated by the inverter. The inverter serial number, again, it's easy to find in the information menu, and the status for device, for battery, for backup, or for the grid, and a whole list of battery management system BMS information. And so these are information that are being transmitted by the battery to the inverter in order to show the battery voltage. So this is it's not this value, the BMS battery voltage is not measured by the inverter, it's just sent by the battery. Battery current, some charging or discharging limits, if these are set by the BMS. SOC value, so the state of charge and its status. And again, there's going to be a screen with the meter information. This will be helpful if you are trying to troubleshoot, for example, or to find out if that CD clamp is in the correct direction. This information here in the meter information is going to help you quite a lot, because here you're going to see a value for meter power, and that's going to be either a positive or a negative. Always a meter power, power that is being exported into the grid is a positive, and energy that is being imported from the grid is a negative. We always think of it, well, it's a positive thing that you are exporting into the grid because you're getting money out of it. It's a negative thing because you're importing from the grid, so you have to pay for it. I don't know if this will help you, but it helped me keep in mind what the positive and the negative and what's the meaning for it. Well, this was my my presentation for the hybrid itself. I just wanted to add to this presentation just a few words about the monitoring platform. We're going to make this this presentation available to you. So here I have shared some information about the data loggers that we have currently available, which I mentioned that can be data logging, Wi-Fi, GPRS, or LAN. The Wi-Fi one is the one that needs a little bit more, some configuration in terms that it needs to be connected to the data logging to the wireless router of the customer. The other ones don't need any additional configuration. So for this, I have put here for you some links for YouTube and some troubleshooting on how to do this. I know that we don't have too much time, so I'm not able to show you these links, but I'm sure if you have the need, you can check them. For the Solis, I'm just going to mention this, that it's very important. I believe it's very, very important for the customers to purchase their data loggers when you are installing it, because you can install this for them when you're doing the hybrid installation, and afterwards, as soon as you get out from that location, you're going to have access to it remotely, and we're going to have access to it remotely as well in order to help you troubleshoot all of these cases. The Solis, what we are using now, it's the Solis Cloud app. Before we had a different monitoring platform, which was maybe if you're familiar with the Solis Home or Solis Pro. If you have accounts on the old platforms, it's quite easy to migrate to Solis Cloud because you can just log in with the same username and details, and it's going to migrate and transfer all those old data and plans that you already have, and it's going to move them here. And you can create accounts for your customers as well from your installer account. But also, if you're not doing this, the customer can create it for themselves as well. And they can give you access later on if they want to. What I want to add, it's a little bit about the troubleshooting process. So normally, if you have a case that you would kind of need our support, we always advise you to give us a call while you are on site, or if you don't do this, at least try to gather all the information possible, take all the measurements, pictures, even videos with what's happening, and you can send them to us. If you send an email to euservice@solisinverters.com, it will automatically raise a ticket and someone will help you. Or if you're on site and it's urgent, you can call our service line and we can help you with it. And keep in mind that an RMA process, I mean, if an inverter is indeed confirmed as faulty, it needs to be confirmed first from our side. So if you think that a unit needs replacement, it's best to contact us while you are there on site, help you do all the tests, and then get the confirmation from us, and we can go up from there. We can also arrange for the delivery of the new unit and pick up the faulty one. And again, here I have included as knowledge base that you can use. We have a list with a lot of. Let's see if I'm able to open it from here. Yeah. So we have a lot of materials that you can use, or you can consult even when you're not on site. If you want to check things about our inverters, about storage inverters, a lot of troubleshooting, or tips and tricks on how to install resetting pile and tech batteries, for example, or how to set a zero export or set up a BYD battery. We have the link where you can find all our certificates and user manuals. We have installation videos on our YouTube channel for Solis inverters, and also the design tool that for now it's just available for the PV. You cannot, for the PV side of the inverters, you cannot use it for the storage side for battery, but hopefully it will be updated really soon. Yeah, and yeah, that was